In this video, I'm going to talk about first-order differential equations. But first, we have to know what a differential equation is. Here's an example. dy over dx is equals to minus x over y. Here we have derivative of y with respect to x, which is equal to an equation in terms of x and y. The key idea is to rearrange the equation in such that we have y in one side of the equation and x on the other side of the equation. So how do we solve this? We will use a technique called separation of variables. As the name suggests, we will do it like that. Note that you can also treat dy and dx as separate variables so that you can do normal math operations on them. So y dy is equals to minus x dx. Now we can integrate both sides of the equation. So we have 2. Then we have constant. So this is the final equation of y in terms of x. To get a more simple equation of this, we can rearrange them like this. Y squared plus x squared is equals to 2c. So we finally have an equation which basically represents the equation of a circle, which we know that x squared plus y squared is equals to r squared. So we have r squared is equals to 2c. So since we have a constant c, it basically represents that we can have a family of circles of different radius. So let's say we have c as 1, then we can have a radius of 1. Then the circle will be like this with radius 1. Kind of inaccurate. Yep. So this happens when c is equals to 1. So let's say we have c is equals to 2, then we can have a radius of 2. So this happens when c is equals to 2. And let's say when we have c is equals to 4.5, we can have a radius of 3. Here's another example that we can work on. dy over dx is equals to minus y over x. And just like before, we will use separation of variables to solve this problem. So we have 1 over y times dy is equals to minus 1 over x times dx. And then we will integrate both sides of the equation. Dx over x. So integration of 1 over y gives us ln y. This is equals to integration of 1 over x gives us minus ln x plus constant. Then we have ln y plus ln x is equals to C epsilon times Y equals to C. So if we take out the logarithm, we have xy is equals to e to the power C. And if I have finally y is equals to e to the power C over x. You can consider e to the power C as some constant a for the ease of the answer. So we have an equation which is y is equals to a over x. And note, since we removed the absolute modulus from the equation, we have to add the equation could be negative or positive. So we have to add plus minus a over x for the final solution. So this is an equation of asymptotes y. So if a is positive, then we have some curves. This is like this. If we have a more than this, then we have, if a is some negative number, then we have curve like this. For more smaller values of a, have like this and this. But what if we had a more complicated problem where we cannot use the separation of variables? So we can see from here, the terms involving x and y are mixed together, so that approach will not work here. So we need to think of another way. Take your time and try to solve this. We can use the product rule, where if we have an equation that if we try to differentiate them, two terms involving uv, final answer will be u dv over dx plus v du over dx. We can recognize if we try to equate u equals to x cubed and v is equals to y, we can see that du over dx is equals to 3x squared and dv over dx is equals to dy over dx. So using this approach, we can find that you can simplify this line of equation as d over dx of x cubed y is equals to sine x. And just like before, we integrate both sides of the equation of derivative of x cubed y and integration of sine x dx. Here, the integration of derivative of x cubed y just results in the same equation, x cubed y. And here we have sine x. The integration of sine x gives us cosine of x plus c. And here we have y is equals to minus cosine of x by x cubed plus the constant over x cubed. So this is the final answer to the equation. All the problems that we have worked on so far are called first orders. First order differential equation. The reason they're called first order, it's the first derivative of the function fx or the variable y. We can also have higher order differential equations. For example, second order, we can have equations involving d squared y over dx squared, and also third order, for example, d cubed y over dx cubed. I'll talk about the first order differential equations in the future videos involving different techniques to solve the problems. And if you have any questions or any other problems that you want me to work on, comment down below and I'll answer them. Thank you.